Okay. Adding and subtracting unlike fractions. So just to be clear, to add or subtract a fraction, there is something that you must have. What is that must? Does anybody remember? Colton, what do you remember? Common denominator, right. And that basically means that when you are adding and subtracting, you have the same thing. Adding and subtracting fourths. They both have to be fourths in order for you to come up with a clear answer. Okay, you must have a common denominator. Now in yesterday's lesson we reviewed how to add and subtract when you have that common denominator. Today we're going to review how to add and subtract when you do not. Okay, example 1, and we're on page 231 starting with letter A. 5/12 added to 1/3. I prefer to write it up and down. I don't care how you write it. You can do it your way. Now, what multiples do 12 and 3 share? Because clearly you have to change it. 12 is right. We are going to change the bottom fraction to twelfths. In order to convert thirds to twelfths, we need to multiply 1/3 by a fraction equal to 1 that renames both terms. That fraction equal to 1 is 4/4. So our new fraction is 4/12. The answer is 9/12. Can 9/12 be reduced?
Yeah.
By what?
3.
Good job. You end up with 3/4. If you do not reduce it, I have to mark it wrong. It is required that you simplify. Okay? You have to simplify. Subtraction. This is letter B. A negative 5/6 minus 7/9.
Kayla Peters to the office, please.
Now, what I taught my Algebra 1 students, and I'm not sure if we discussed this in this class or not,
Michael Markson to the office, please.
was that when you are subtracting, one way of thinking about it to make sure you don't make a mistake is to make the second item adding the opposite of the second item. Okay? Adding the opposite of the second item. By definition, that's what subtraction is. In elementary school, subtraction was removing something from a bigger group. Okay? Now that you're older, I can explain it this way, and the reason I think this is important is because now it helps you to recognize that you're going to be combining these two items, and the end result is going to stay negative. But before we do all that, what can we convert both of these numbers to? What is the least common multiple that they both share? Go ahead. 18 is right. You both say 18. I'm going with 18. Okay. To convert this one to 18ths, we're going to multiply it by a fraction equal to 1, which is 2/2. To convert 5/6 to 18ths, we're going to multiply it by a fraction equal to 1, which is 3/3. Now in the bottom, I have negative 14/18, and in the top, I have negative 15/18. Okay? The combination is negative 29/18. As a mixed number, it's negative 1 and 11/18, which cannot be reduced. That is your final answer there. All right? Any questions on example 1? Moving on then to example 2. Turn the page with me. Just because they look ugly and tricky like in example 2 doesn't change the technique. Adding or subtracting mixed numbers. Okay, so above was just simple fractions. Now we're going to deal with mixed numbers. They've got negative 4 2/5 being added to negative 2 6/11. Does everybody see that? The first thing you want to do here, and this is the easiest way to avoid making mistakes, is to change it so that both items are improper. If you don't like doing it this way, that's okay.
Mrs. Myers,
Yes.
can we have Hunter to the office?
Yes.
Thank you.
So I've converted both of these, okay? Now that they are both improper fractions, I can figure out what common denominator to change them to. And the least common multiple of 5 and 11 is 55, okay? This is where your calculators are going to come in handy. To convert the bottom fraction, both pieces must be multiplied by 5. To convert the top fraction, both pieces must be multiplied by 11. So you end up with 22 times 11 is what? Anybody know? Thank you. All right. You all have calculators. You all should be trying to follow along. The sum of this mess is negative 382 over 55. Which simplified is negative 6 and 52 55ths. Okay, you could solve that on your own. Yes, ma'am?
Can't you just
Yes, you can. Leave it like this, convert that, and then deal with the holes. Absolutely, you can. Okay, Haley just said, why in the world do I have to convert them to mix and then raise them to the correct denominator and then deal with this big ugly number? You certainly can. You certainly could have just converted the 2/5 and the 6/11, combined those, and then dealt with the fractions. The only reason this can be problematic is because people make mistakes. All right? I don't care. If it works for you, do it. I have no problem with that. All right, that's example 2. All right, let's go ahead and do example 3. How many more miles? Oh, this is our story on the first page. Chesapeake and the Ohio Canal National Parks. The distance between the campsites is 10 and 1/5 miles. So camp, site A, camp, site B. The distance between the two is 10 and 1/5 miles. You've already hiked 5 3/4 miles. That guy's walking, by the way, he's hiking. You've already hiked 5 3/4 miles. Example 3 says, you've already hiked it. To find the remaining distance, subtract what you've already done. 10 and 1/5 minus 5 3/4. What are we going to convert fourths and fifths to, people? 20 is right. I'm going to leave it a mixed number. I'm going to leave it a mixed number. 10 and 4/20. 5 and 15/20. Okay? Haley, this is what you were talking about right here. 4 minus 15, you can't do it. This is where the problem comes. Borrow from the 10, it becomes a 9, and what I borrowed as a 1 is 20 over 20. Okay? 20 over 20 is what I borrowed because that is the denominator being used. So I add that 20 to the 4, and now I have 24 20s. Okay? 24 over 20 minus 15 over 20. You should end up with 9 over 20. 9 minus 5 is 4. This is the remaining portion of your journey. All right? So this is why the book and some other people will say convert them to improper fractions, because some people will borrow and change that to a 5. Well, that's not what you borrowed. You borrowed a whole number in fraction form with a denominator of 20. Okay? That's example 3. Moving on to example 4. Simplify the expression a over 2 minus a over 6. Okay? A over 2 minus a over 6. First things first, do we have the same denominator?
No.
What can we convert 2 to? 6. Okay? In order to do that, I'm going to move this over as it sits. In order to do that, we need to multiply this top fraction by a fraction equal to 1 that would create 6 in the denominator spot. Okay? Now, what is 3 times a? 3a is right. Okay? Now you can make this, add the opposite if you like. That seems to be the way I do it. Add the opposite. So a 3a and a negative a is how many a? 2a. 2a over 6 is your answer. Now you've already learned how to reduce these kinds of things. You've learned that you take your fraction, I usually stretch it out like that. I draw a line, you don't have to, but reduce to 6, what does it become? 1 over 3. The a sits where it was. So your answer is 1a over 3. A over 3 is how I would write it, because when the coefficient is 1, it is not necessary to write it. This is the proper answer. Okay? That is the proper answer. In the guided practice, number 7. Okay, I'm going to continue. I think everything else is easy except for this. Guided practice. This is number 7. Number 7 says, simplify the expression a over 15 plus a over 6. Least common multiple of those two things. 30 is right. Very good. What fraction equal to 1 will I multiply this one by? 2 over 2. Very good. So I get 2a here. What fraction equal to 1 will I multiply the second fraction by? 5 over 5. So I have 5a over 30 being added to 2a over 30, which looks like 7a over 30. 7 and 30 do not share anything, so they cannot be reduced. Okay? Don't expect every one of them to be reducible. Okay? b over 8 plus, this is the next one, b over 12. Let's change these both to 24ths. Okay? 2b, because we multiplied it by 2 over 2. 3b, because we multiplied it by 3 over 3. You should end up with 5b over 24. Okay?